we look at an example for equivalence classes. So after we determine a relation that is equivalence relation, we have the base set S, and suppose we're gonna put a few numbers in here: -5, -4, -3, -2, -1, 0, and I'm gonna just pick some maybe random numbers here, and 6. So we're going to define a relation, so the relation is defined as, let's call it a relation R. If X is related to Y, if and only if 2 goes into X minus Y. So by this relation, I'm going to list all the numbers which are related to each other. So I'm going to randomly pick, for example, a number from the base set S, pick -5. And -5 is related to which number? And I can check the rest of the numbers. So for example, -5 is -5 related to -4? Apparently not, because -5 minus -4 will be -1, and 2 does not go into -1. So -5 is not related to -4. But -5 is related to -3, because when I plug in there, so I'm trying to check, is -5 related to -4, which is not. So this is not. And I'm going to check, I'm just going to put a line through R, which means -5 is not related to -4. But -5 is related to -3. Let me also give you the reason here. Why? Because why is -5 not related to -4? Because by the definition, this is our X, this is Y, and you plug in there, 2 does not go into -5 minus -4, because -5 minus -4 is -1. So similarly here, we can check 2 actually goes into -5 minus -3, because we will get -2. So similarly, we keep doing this. -5 is -5 related to -2, the next number? Not. Actually, if you're very familiar with the numbers properties, you know that 2 has to go into an even number. And if one of the numbers is even -2, the other is odd, the difference will definitely be odd. We can prove that. Odd number minus an even number is going to be odd, and 2 will not go into an odd number. So, and because -5 is odd, and it has to subtract another odd number in order to get an even number, so 2 can go into that even number. So you can see, if you understand that, and then it will be very easy for us to determine -5 is going to be related to. I'm gonna list all of them here. So -5 is related to, gonna put them in order pair. -3 and -5 is related to -1. -5 is related to 1. -5 is related to 3. -5 is related to -5 itself. Actually, I forgot to use it itself. So the relation here we defined is from S to S. So the first component, X, comes from S. Y also comes from S. Okay, so that's all the order pairs for -5. So now we look at the -4. Of course, -4 itself, because when you subtract them, you get 0. 2 goes into 0. And because -4 is even, in order to make the difference to be even, you got to make sure you pick an even number. So -4, you cannot do it with -5, you cannot do it with -3, but we can pick -2 and -4 with 0, -4 with 4, negative 4 with 6. So difference will always be even, so 2 will go in there. Okay, now let's start with negative 3. Negative 3 is odd, so we can pick another odd. Start with negative 5, and negative 3 with negative 1, negative 3 with 1, negative 3 with 3. Okay, now let's look at negative 2. Negative 2 with negative 5, it doesn't work. Negative has to be even, so and I pick up the rest of the even numbers in the set. 4, negative 2 is 6. Okay, and then we continue this. Next 1 has to be odd, so pick a negative 5, negative 1, pick negative 3, negative 1, pick negative 1, and negative 1, pick 1, and negative 1, pick 3. Okay, and now let next start with 0 with all the even numbers. With 0 itself, and then 0 with 4, 0 with 6. Okay, so I'm done with 0. Now let's try 1. So 1 with all numbers, negative 5, 1 with negative 3, 1 with negative 1, 1 with 1 itself, and 1 with 3. Now we pick 3, so 3 with negative 5, 3 with negative 3, 3 with negative 1, 3 with 1, 3 with 3. That's it. And this next we have 4. So 4 with we have to pick an even number. Negative 4, 4 with negative 2, and 4 with 0, and 4 with 4, and 4 with 6. And we last one, 6. 6 with negative 4, 6 with negative 2, 6 with 0, 6 with 4, and 6 with 6. Okay, so if we put all these order pairs in the curly brackets, all of them in curly brackets, and that will and this relation is going to be an equivalence relation. And so I'm going to skip the proof there. Because we are trying to emphasize equivalence classes. So how do we determine the equivalence class? I did list all the order pairs, all the in each pair these two numbers are related. So when we do equivalence, try to find equivalent classes, we are looking at the base set S first. So pretty much your goal is to divide the set S into different partitions, different parts groups, and by a certain relation. So here, what is the relation given? It's this relation given. So what you're gonna start with the first number, say negative 5. So I'm gonna put negative 5 in the set. A set means a group, and I'm gonna put all the numbers related to negative 5 in the set. So what number is related to 5? There's a negative 3, negative 1, there's a 1, there's a 3, and there's another negative 5. Negative 5, of course, it's already in there. So negative 3, negative 1, and 1, and 3. Any other numbers related to negative 5? Well, you can see this. We have already included everything, right here, and all these numbers have already been included in there. So it looks like that's all we have. And then, so I already used this and this, negative 3, negative 1, 1, and 3. All these numbers are in the same group. Now, I'm going to pick a number that I haven't used. It's not in that first group. So let's pick negative 4. What numbers are related to negative 4? Negative 4 itself, and negative 2, and 0, and 4, and 6. So I'm going to put all these numbers related to negative 4 in the same group as negative 4. the same set. And you can see, you can double check that these are all we have, all the numbers. And so we also -4, -2, 0, 4, and 6, and no number left. That's all we have. So we got, originally we got 4, 8, 10 numbers, and now I use this relation. 2 goes into the difference of these two numbers to divide the set 10 numbers into 2 groups. Each group has 5 numbers, but sometimes they don't have to have the same number of numbers. It could be one group has 2 numbers, another group has probably 8 numbers. It's possible. It really depends on what the relation is. So each of them here is called an equivalence class. So that's equivalence class. That's equivalence class. So what is the definition of equivalence class? In each class, you have to make sure every 2 are related. So these 2 are related, these 2 are related, these 2 are related, these 2 are related, and also -3 and -1 are related. See, we have it here. -3 and 1, they're related. -3 and 3, they're related. And also -1, 1, they're related. So we have all these, everything. So -3, -1, 1, it's right here. Okay. Well, and so as long as it's an equivalence relation, if you check the first few, and then you should get all of them. And then similarly, every 2 in this group, they're also related. So we only got 2 equivalence classes. And also make sure every number in the base set is in one of the groups. Sometimes you may have a group which has 1 person. So let me give you a real life example here. So if I have a few people, say Bob, Ann, and Smith, and Josh, and say David, and that's the base set. Now if I define the relation as the gender relation, so if X is related to Y if and only if X has the same gender as Y. In this case, and this is also definitely a equivalence relation. You can double check the reflexive, symmetric, transitive property. This relation satisfies all these 3, so it is the equivalence relation. And if it is the equivalence relation, then we can divide the base set into different groups based on this. So even if we don't list all of them, we can actually do that, because now first I'm going to pick Bob and try to determine which people are belong in the same group as Bob. So by looking at the definitions, who will be related to Bob if Bob has the same gender as this person? And so Bob is, if we assume it's a man, and then Smith is also a man, so Bob and Smith, they're related, and Josh is a man, and David is a man, so we have everybody except Ann in this group. So this is picked, they're all in the same group. Now we only have 1 person left, which is Ann, and Ann will be in this group by herself. So you can see by using this gender relation that we divide these 5 students into 2 groups, 1 male group, the others female group. And each of them is the equivalence class. But if I define a different relation, say the relation is the age relation, if I tell you, say Bob is 10 years old, and 2 years old, and 2 years old, and 3 years old, and then you will have, based on the, if X is related to Y, if and only if X has the same age as Y, and then we pick Bob, so who has the same age as Bob, and then only has Ann, and then these are only 2. And then we look at Smith, who is related to Smith, because this time the relation is age, same age. So we have Smith and Josh in the second class, and David is the only 3-year-old, so he's in 1 class.